Hello everybody, welcome into another lesson. So today we are going to graph the tangent and cotangent functions. So here you have f of x equals the tangent of x. And you see the graph here, it almost looks like f of x equals x to the third. It looks almost identical to it. And it does this infinitely, from negative infinity to infinity. You still have an amplitude on the tangent function. It's the coefficient on the tangent. In this case, it's 1. Now, your other four functions, your period is 2 pi, but with tangent and cotangent, your period is only pi. It completes one full cycle in a period of 1 pi. So the period is just pi for tangent and cotangent. And then your domain is all real numbers except where x equals odd multiples of pi over 2. The reason being is, we think of tangent, that's sine over cosine. Well, at pi over 2 or 3 pi over 2 or any odd multiples of pi over 2, you would either have 1 over 0 or negative 1 over 0, which would make the expression undefined. And thus, where it's undefined would produce vertical asymptotes where x equals odd multiples of pi over 2. Now your range is different. Your range is the entire set of real numbers. You go from negative infinity to infinity. So here you see the graph. You have your critical points 0, pi over 4, pi over 2, 3 pi over 4, and pi. Where at 3 pi over 4 it's negative 1, pi it's 0, pi over 4 it's 1, 0 it's 0, negative pi over 4 it's negative 1, negative 3 pi over 4 it's 1, and then negative pi it's 0. And it'll do this infinitely. It'll cycle through infinitely. So there's the standard tangent of x. Now let's get on to graphing the cotangent of x. Of course, I should probably plot the same points again as the tangent, but this time we're going to do the basic graph of f of x equals the cotangent of x. Alright, there, all the critical points are plotted. Now, f of x equals the cotangent of x. Again, you have an amplitude of 1. Your period's still pi, but let's think about where the cotangent's undefined. Really, it's going to be any integer multiples of pi. If we take the cotangent of 0, you would get, of course, cotangent's cosine divided by sine, so you would get 1 divided by 0. That's undefined. If you take pi or negative pi, you would get negative 1 divided by 0, which is undefined. So your domain is all x except x equal to integer multiples of pi. Alright, which would produce vertical asymptotes where x equals integer multiples of pi. And your range is still going to be all real numbers. So let me draw these asymptotes real quick here. So you're going to have a vertical asymptote at x equals 0, x equals pi. Then you'll have another one at x equals negative pi. Alright, so let's graph this. So the cotangent of pi over 4 is 1. the cotangent of pi over 2 is 0. The cotangent of 3 pi over 4 is negative 1. So here's what we're up against. Alright, negative pi over 4, it's actually going to be negative 1. Negative pi over 2 is 0. Negative 3 pi over 4 is 1. So here's going to be that graph. And there is the graph of your cotangent function. It looks like a reflected tangent. Basically it is. And it'll do this infinitely from negative infinity to infinity. So there's the standard graph of the cotangent function. Now let's talk about some reflections. Alright, so let's plot our critical points again. Pi, 3 pi over 4, 6, 5, pi over 2, pi over 4, negative pi over 4, negative pi over 2, negative 3 pi over 4, and then negative pi. Alright. We're going to do f of x equals negative of the tangent of x. So we have a negative 1 coefficient on the tangent of x. Well, like the other trig functions, the amplitude's the absolute value of your coefficient. In this case, the absolute value of negative 1 gives you an amplitude of 1. Your period hasn't changed. That's still pi. Your domain is still your domain's not affected by this. Your domain is still all of x not equal to odd multiples of pi over 2. Your range isn't even affected. It's still all real numbers. And then your asymptotes are x equals those odd multiples of pi over 2. The only difference is going to be you actually have a reflection in both the x and the y-axis. Why is it a reflection of the y-axis? Well, let's say I took the tangent of negative x. Well, isn't tangent an odd function? That would just make it the tangent of x, the negative tangent of x, so you would actually have a reflection in both axes. So you have a reflection in both the x and y axes. Alright, so let's plot these asymptotes here. Alright, so let's start at the tangent of 0. Tangent of 0 is just 0. That's an easy one. How about the tangent of pi over 4? That's normally 1, but with that negative sign, that would actually make it negative 1. How about the tangent of negative pi over 4? That's normally negative 1, but if you negate that, you'll get positive 1. So you're beginning to see this is going to look actually a lot like a cotangent graph, only where it's shifted horizontally. Alright, tangent of pi is normally 0, still 0, even with the negative sign. Tangent of 3 pi over 4 is normally negative 1, but if you negate that, you actually get positive 1. So here's your curve there. Now, the tangent of negative pi is still 0. Now, the tangent of negative 3 pi over 4 is normally positive 1. You negate that, you get negative 1. So, there is the graph of the negative tangent of x. It just looks like a horizontally shifted cotangent. And of course, you know what's coming now. We got to reflect the cotangent. Any guesses as to what that's going to look like? If you guessed a reflected tangent, then you'd be right. That's pretty much what it's going to be. Or a shifted tangent, I should say. So yes, we are going to do f of x equals the negative of the cotangent of x. So let's plot all those points here, which are very important. 7, 6, 5, here's pi over 2. 4, 3, 2.5 is pi over 4. 3, 4, 5, there's negative of pi over 2. 6, 7, so that's negative 3 pi over 4. Okay. So the negative of the cotangent of x still produces a reflection in the x and y axes. And your amplitude is going to be the absolute value of that coefficient of negative 1, just giving you an amplitude of 1. Your period is still pi. Now your domain, so again, your domain is x not equal to those integer multiples of pi. Your domain hasn't changed. Which would also then produce x, it would produce vertical asymptotes at x equals those integer multiples of pi. Alright, so let's get the asymptotes going. There's definitely one at x equals 0. Next one is going to be at x equals pi. And then you'll have one at x equals negative pi also. That'll be another vertical asymptote. Alright, so let's start with pi over 2. The cotangent of pi over 2 is still 0. Now, here's where it gets fun. Cotangent of pi over 4 is normally 1, but if you negate that, you'll get negative 1. Cotangent of 3 pi over 4 is normally negative 1. You negate that, you get positive 1. So yes, you're going to begin to see this is just going to look like a horizontally shifted tangent graph. Cotangent of negative pi over 2 is still going to be 0. Alright, so the cotangent of negative pi over 4 is normally negative 1, but if you negate that, you get positive 1. Cotangent of negative 3 pi over 4 is normally positive 1. You negate that, you get negative 1. So, indeed, this reflection in the cotangent just looks like a horizontally shifted tangent graph. Alright. Now let's talk about some vertical stretches and shrinks. In fact, I think we'll even keep the function the same this time. The only thing we're going to change is the amplitude. Alright, so we'll have f of x equals 2 times the cotangent of x. Let me label all those critical points. 8 or 7.5, so that's 3 pi over 4. 7, 6, 5, here's pi over 2. 4, 3, alright, so here's pi over 4. negative pi over 4, negative pi over 2, 6, 7, so there's negative 3 pi over 4, and then negative of pi. Okay, there's all the labeled points. Now, f of x equals 2 times the cotangent of x. So the amplitude's the absolute value of that constant, on the coefficient rather, so the absolute value of 2 is just 2. Your period still hasn't changed, which we'll get to period changes in a bit. It would only change if you had a coefficient on the x, and you only have a coefficient of 1. So period's still pi. The domain hasn't changed. X still not equal to integer multiples of pi, which means your asymptotes are at x equals those integer multiples of pi. We don't have a reflection. I can get rid of that. Your range is still all real numbers. So let's go ahead and plot these asymptotes just for our benefit here. Got one at 0. We also have one at negative pi. Okay, now what does that 2 do? It's a vertical stretch factor of 2. So we have a vertical stretch of 2. So let's start at pi over 2. The cotangent of pi over 2 is 0, while 2 times 0 is still 0. Now what's the cotangent of pi over 4? That's 1, but times 2 is actually 2. And then 3 pi over 4 is negative 1 times 2 is negative 2. So this is going to start to stretch this a little bit here. Alright, cotangent of negative pi over 2 is 0. Cotangent of negative pi over 4 is normally negative 1. Take that times 2, you'll get negative 2. Cotangent of negative 3 pi over 4 is 1. Take that times 2, you get 2. So, yes, you have a vertically stretched graph by factor of 2. And then, of course, we'll do an example with the tangent graph. And then we'll move on to vertical shifts after that. Alright, so f of x equals 1/2 of the tangent of x. So we're going to do f of x equals 1/2 of the tangent of x. So let me label all the critical points here. Here's 3 pi over 4, 765, pi over 2, 4, 3, here's pi over 4, negative pi over 4, negative pi over 2, negative 3 pi over 4, negative pi. Alright, so there's all the critical points labeled. So again, let's look at the amplitude. The coefficient on tangent is 1/2. So the amplitude is going to be the absolute value of that 1/2, which would give you an amplitude of 1/2. The period's still pi. The domain, so that's x not equal to those odd multiples of pi over 2. Which is going to produce vertical asymptotes where x equals those odd multiples of pi over 2. Alright, your range is still all real numbers, and then since the coefficient is less than 1 but greater than 0, you have a vertical shrink of 2. You have a vertical shrink factor of 2. So let's draw these asymptotes real quick. That might aid us a little bit. Yikes, that was really out of whack. I don't want to do that. Heck, when I was younger, I struggled with coloring, with staying in the lines. That's why I was never an art major. But I digress. Okay. So the tangent of 0 is still 0. That hasn't changed. Now, the tangent of pi over 4 is normally 1. Take half of that, you'll get a value of y being 1/2. Tangent of negative pi over 4 is normally -1. Take half of that, you'll get -1/2. So there's going to be your graph. And I will say sometimes it's harder to notice vertical stretches and shrinks, but it definitely hugs the x-axis more. Alright, tangent of pi is just 0. Tangent of 3 pi over 4 is -1. Take half of that, you'll get -1/2. And then tangent of negative pi is 0. Tangent of -3 pi over 4 is 1. Half of that's a half. So yes, it tends to hug the x-axis more. This is vertically shrunk. Okay. So that's it for the vertical stretches and shrinks. Let's go on to vertical shifts now. We are going to do some vertical shifting. What you're going to see for these functions is actually not as bad as you think. We'll leave that alone. Yeah, we'll leave that alone. Okay. I got some of the critical points up. Let's see, 7, 6, 5. Here's negative pi over 2. Whoops, I want to do that in brown. There, negative pi over 2, negative pi over 4, positive pi over 2, positive 3 pi over 4. Okay. So let's do some vertical shifts. Let's say I do 2 plus the tangent of x. So now I have something plus or minus the tangent. Well, again, let's look at your amplitude first. The coefficient on the tangent itself is 1, so the amplitude's the absolute value of 1, which is just 1. Your period still hasn't changed because the coefficient on the x is 1. Your domain still remains the same, x not equal to those odd multiples of pi over 2, which will give you the asymptotes, the vertical ones, at x equals the odd multiples of pi over 2. In fact, let me go ahead and get those asymptotes drawn real quick. Alright, got the asymptotes drawn. Your range is still going to be all real numbers. So since the range was already all real numbers, negative infinity or infinity plus 2 really isn't going to be affected. So your range is still all real numbers. The difference is you have a vertical shift up 2 units. Because of that plus 2, that 2 plus. So let's go ahead and graph this. The tangent of 0 now is normally 0, but if you add 2, you'll actually have a y-coordinate of 2. The tangent of pi over 4 is normally 1. If you add 2, you'll have a y-coordinate of 3. The tangent of negative pi over 4 is normally negative 1. If you add 2, you'll get positive 1. So here's what you're up against. Alright, so everything's been shifted upward to. Your tangent of pi is normally 0, but you add 2, you'll actually have a y-coordinate of 2. Tangent of 3 pi over 4 is normally negative 1. If you add 2, you'll get positive 1. Okay, and then we have negative 3 pi. Sorry, let's do negative pi. That would normally give you 0. You add 2 to that, you'll get 2. Negative 3 pi over 4 is normally 1. You add 2 to that, you'll get 3. So there are your vertically shifted tangent curves. Everything was shifted upward 2 units. And now, of course, we have to do one with the cotangent. It's only fair that we do that too. That's not even going to change. Alright, so let's do f of x equals negative 3 plus the cotangent of x. So f of x equals negative 3 plus the cotangent of x. Whoops, I should probably label some critical points. Thankfully, it's only a couple that I'm missing. There we go. Alright. So the coefficient on the cotangent itself is 1, so the amplitude is 1. The period still hasn't changed, that's pi. Your domain's not even going to change. For the cotangent, it can be all of x except x equals integer multiples of pi. So x cannot equal integer multiples of pi. Which gives you the asymptotes for the vertical asymptotes at x equals those integer multiples of pi. Alright, your range still stays the same for all real numbers. Now that plus the negative 3, that means a vertical shift down 3. So everything's going to shift down 3 units. And then we'll label the asymptotes and we should be good. Alright, so asymptotes at pi, we already got one at 0. That's just going to be the y-axis. It's kind of hard to draw over that with that blue. And then we'll have a vertical asymptote at negative pi. Alright, so let's start with the cotangent of pi over 2. That's normally 0, isn't it? But if you subtract 3 from that, you'll be all the way down to negative 3. Now the tangent of pi over 4 is normally going to be 1. If you subtract 3 from that, you'll be down at negative 2. And then the tangent of 3 pi over 4 is normally negative 1. You subtract 3 from that, you'll be all the way down to negative 4. So there's everything being shifted down 3 units, and then the cotangent at negative pi over 2 is normally 0. Subtract 3 from that, you'll get negative 3. Cotangent of negative pi over 4 is normally negative 1. Subtract 3 from that, you'll be down to negative 4. Cotangent at negative 3 pi over 4 is normally positive 1. Subtract 3 from that, you'll be down to negative 2. So here's your cotangent curves shifted downward 3 units. Alright, so we've done vertical shifts. Now let's talk about horizontal shifts. And I think we'll start this time with the cotangent graph since everything's already set up for that. Alright, so the domain and range haven't changed so far. For what we're about to do, the range won't change, but the domain certainly will, which would also change your asymptotes. So let's say we have the cotangent of the quantity of x plus pi over 4. So now we have a quantity inside the cotangent. We have the cotangent of x plus pi over 4. Well, I could probably at least get rid of those asymptote markers, because the reason I'm saying that is this will affect our domain. Why did I put pi over 4? It's just negative pi and then pi. Okay. So let's take notice of something here. The amplitude's still 1 because the coefficient on the cotangent is 1. Your period's still pi because the coefficient on x is 1. Your range is still going to be all real numbers. But what's changed? Well, let's look at that x plus 4. If you set x plus 4 equal to 0, you'll get x equals negative pi over 4. So you have a horizontal shift left pi over 4. Well, that's going to shift your asymptotes. So if we're going left pi over 4, what does that mean? That means from pi over 2, we go left pi over 4. That'll put you at an asymptote of pi over 4. So let's draw an asymptote of pi over 4. Now your next asymptote was at negative pi over 2. Well, that's going to actually put you at negative 3 pi over 4 for an asymptote. So your asymptotes have shifted. So what is true? This is actually then going to be at any multiple of pi over 4 plus or minus pi. So your domain is all real numbers except x equals pi over 4 plus or minus pi. So that's a really weird domain. The reason I say that is because at negative pi over 4, so wait, pi over 4 would give you, let me look at this here. We shifted everything left pi over 4 units, so you know what? I made a blunder here. Just a second. Yes, it's true we shifted left pi over 4, but what does that really mean? That still hasn't changed, but I realize what I just did here. Alright, just got to label 2 more points then. There's your pi over 4. Okay. Well, let's see. If we put in 3 pi over 4 rather, So 3 pi over 4 would give us the cotangent of pi, which is going to be undefined. Let's see, negative pi over 4 would give us the cotangent of, that would give us 0. I mean, that would give us undefined because you'd have the cotangent of 0. So yeah, that makes sense. I don't know why I was thinking of the tangent graph a minute. Forgive me for that, folks. Alright, that should be all of our asymptotes there because even negative pi isn't going to cause that. Okay. We're good. I was thinking, you see, it's easy to do, think of the other function, but everything shifted left pi over 4, so from pi you would get 3 pi over 4. From 0 you would get negative pi over 4, and then by the time you get to negative pi, you're out of the picture. Okay. So what is true for your asymptotes? Your asymptotes are going to be, well, it's going to be x not equal to pi minus pi over 4. I should say plus or minus pi over 4. Now, how would I write that? Pi actually, it's probably best to write it as negative pi over 4 plus or minus pi. So your domain is all of x except it not equal to negative pi over 4 plus or minus pi, which means your asymptotes are going to be at x equals negative pi over 4 plus or minus pi. Alright, so we got everything labeled. Now let's draw this horizontally shifted cotangent. This time we can pick 0. So if you put in 0, you'll get the cotangent of pi over 4, which is actually 1. Wrong color marker. Alright, if we pick pi over 4, you get the cotangent of pi over 2, which is actually 0. If you pick pi over 2, you'll get the cotangent of 3 pi over 4, which is negative 1. So here's what you're up against. Alright, if I pick pi, I would actually get the cotangent of pi over 4, which is going to end up being positive 1. And it's actually going to go up like this. Alright, if I pick negative pi over 2, I'll get the cotangent of negative pi over 4, which is negative 1. If I pick negative 3 pi over 4, I'll get the cotangent of negative pi over 2, which is 0. If I pick negative pi, I'll get the cotangent of negative 3 pi over 4, which is positive 1. So yes, you have this really weird cutoff to the left and even to the right. So this is a horizontally shifted cotangent graph, pi over 4 units to the left. I know that's really weird, but that's exactly what it is. Alright. Now, of course, I got to do a shift with the tangent. Yeah, let's keep that the same. Those are going to change. Let's just, before I go any further, let me label these points. So there's negative pi over 2, negative pi over 4, positive pi over 2, positive 3 pi over 4. Alright. So f of x equals the tangent of the quantity of x minus pi over 4. So now we have the tangent of the quantity of x minus pi over 4. So let's look for your amplitude. The coefficient on tangent's still 1. That'll give you an amplitude of 1. Your period's still pi because the coefficient on x is still 1. Your range is still all real numbers. Now if you take that x minus pi over 4, set it equal to 0, you'll get x equals positive pi over 4, which means you actually have a horizontal shift to the right pi over 4. So everything's shifting to the right pi over 4 units. What does that mean? Well, consider your normal asymptotes. Pi over 2 is definitely a normal asymptote, so if you shift it to the right pi over 4, you'll be at 3 pi over 4. That'll give you an asymptote at 3 pi over 4. Okay. Your next asymptote is normally located at negative pi over 2, but if you shift it to the right pi over 4, you'll be at negative pi over 4 for an asymptote. And then we should be good again until we reach negative 5 pi over 4, which is completely out of the picture. So what does that mean for our domain? The domain would also be x not equal to that negative pi over 4 plus and minus pi. So x cannot equal negative pi over 4 plus or minus pi, which means your asymptotes are located at x equals that negative pi over 4, both plus and minus pi. Okay, so we have everything we need. We got our shifted asymptotes. Let's go ahead and graph this. The tangent at 0 is normally 0. Well, tangent at 0, then minus pi over 4 gives you the tangent of negative pi over 4. That's actually negative 1. If you put in pi over 4, you'll get the tangent of 0, which is 0. If you put in pi over 2, you'll get the tangent of pi over 4, which is 1. Alright, now if we put in pi, you'll get the tangent of 3 pi over 4, which is negative 1. And then it just kind of trails off there because we've reached the end of the period. And then if we put in negative pi over 2, you'll end up getting the tangent of negative 3 pi over 4, which is actually positive 1. If you put in negative 3 pi over 4, you'll get the tangent of negative pi, which is 0. If you put in negative pi, you'll get the tangent of negative 5 pi over 4, which is negative 1. So it trails off right there. So yes, these shifted asymptotes, this shift everything to the right pi over 4 causes some really funky changes in your graphs. So these are all your your horizontal shifts. Now we're going to get to some good stuff. Let's get into some period changes. I got 4 more graphs total. We're going to do 2 period changes, then we're going to do 2 with several transformations. So that's all about to change. We'll stick with the tangent for this one, but let me just label those critical points. Is negative pi over 4. Alright. Positive 3 pi over 4. Alright, so all the critical points are labeled. Well, we might want to relabel them in a minute. Let's say we have something like the tangent of 2x. So now all of a sudden you have a coefficient on the x. You have the tangent of 2x. Well, your normal period is pi. To find your period, really it's going to be the period divided by that coefficient on the x. So in this case, you'll have a period of pi over 2. So let me relabel a few of these points here. So this would actually be negative 3 pi over 8, since we're dividing by 2, negative pi over 2, negative pi over 4, negative pi over 8. This will be positive pi over 8, positive pi over 4, positive 3 pi over 8, and then pi over 2. So now we have new critical points. We have negative pi over 2 to positive pi over 2. Okay. Well, what's still true though from the other functions between secant and cosecant, and then now tangent and cotangent? What are your normal asymptotes for the tangent? Your tangent normal asymptotes are x is not equal to, or your domain is x not equal to odd multiples of pi over 2. If you take those and divide by that 2, by the same thing you did for your period, you'll get the domain is x not equal to odd multiples of pi over 4. Which is going to give you asymptotes at x equals those odd multiples of pi over 4. So you can just take your asymptotes, divide by that 2, you'll end up getting pi over 4. Your range is still all real numbers, that hasn't changed. Now let's plot these asymptotes. So you have one at x equals pi over 4, because if you take 2 times pi over 4, well, you'll just get pi over 2, which would produce a vertical asymptote, an undefined value. Then we have negative pi over 4. Alright, so let's start with x equals 0. Well, that would still give you the tangent of 0, which is 0. If I put a negative pi over 8, that would give me the tangent of negative pi over 4, which is negative 1. If I put in pi over 8, that would give me the tangent of pi over 4, which is positive 1. So the graph is going to look very similar, it's just the period's changed. And then if I put in pi over 2, I'll get the tangent of pi, which is 0. If I put in 3 pi over 8, I'll end up getting the tangent of 3 pi over 4, which is negative 1. So yes, it looks very similar, it's just shifted periods. If I put in negative pi over 2, I'll get the tangent of negative pi, which is 0. If I put in negative 3 pi over 8, I'll get the tangent of negative 3 pi over 4, which is positive 1. Alright, so there's the graph of the tangent with a period change. Alright, now I got to do one for the cotangent. It's only fair. As a matter of fact, why don't we just reset that, because the period's going to change again. So let's do, for example, f of x equals the cotangent of 1/2 of x. So f of x equals the cotangent of 1/2 of x. Well, my amplitude's still 1 because my coefficient's 1. Now for my period, I'll take that pi and divide it by that 1/2, which would give me a period of 2 pi. So I'll actually have a full period of 2 pi this time. So let's label all these points here. 2 pi. Here's going to be 3 pi over 2. Here's going to be pi over 2. No, I'm sorry, just pi. Here's pi over 2. Alright, negative pi over 2. Negative pi. Negative 3 pi over 2. And then negative 2 pi. Since the period's based on 2 pi and we want to graph 2 full periods. So, what does that mean for your asymptotes? What are your normal asymptotes of the cotangent? It's x equals those integer multiples of pi, right? If we divide by that pi over that pi divided by that 1/2, you get 2 pi. So if you take that and do the same thing with your asymptotes, you would get even multiples of pi. So the asymptotes are going to be that x equals even multiples of pi. Which would be 0, 2 pi, negative 2 pi, so on. So x equals even multiples of pi would give you your asymptote, which means your domain is all of x not equal to even multiples of pi. So now let's plot our asymptotes. We definitely have 0. That would mean 2 pi is an asymptote. X equals 2 pi. And then, of course, x equals negative 2 pi. That would also be an asymptote. Alright, so let's go to pi over 2. If I put in pi over 2 for x, I would get the cotangent of pi over 4, which is 1. If I put in pi, I would get the cotangent of pi over 2, which is 0. If I put in 3 pi over 2, I get the cotangent of 3 pi over 4, which is negative 1. And then if I put in negative pi over 2, I'll get the cotangent of negative pi over 4, which is negative 1. If I put in negative pi, I would get the cotangent of negative pi over 2, which is 0. If I put in negative 3 pi over 2, I would get the cotangent of negative 3 pi over 4, which is positive 1. So as you see, yes, it looks a lot like the original cotangent, only the periods have changed. Now we have a full period of 2 pi as opposed to pi. And then we just got 2 more graphs, then we're done. We're on the home stretch here. The last 2 are going to be the several transformations ones like we've been doing in the past 2 lessons. So basically all this is about to change, except for the range. The range never changes, but everything else is going to. So let's say I do negative 3 minus 2 times the tangent of x plus pi over 4. No, that's not what I wanted to do. Let me shift this a little bit. F of x equals negative 3 minus 2 times the tangent of 2x minus pi over 2. So we have a lot going on here. We have f of x equals negative 3 minus 2 times the tangent of the quantity of 2x minus pi over 2. Well, let's look at our amplitude first. What's the coefficient on the tangent? That's -2, right? So the amplitude would be the absolute value of that -2, which would just be 2. All right, let's look at our period. The period is going to be that the pi divided by that coefficient on the x of 2. So you actually have a period of pi over 2. At that point, we should probably start plotting the critical points of the graph. 9, 8. So there's going to be 3 pi over 8. 7, 6. Here's 5. There's going to be pi over 4. 4, 3. So here's pi over 8. So here's -pi over 8, -pi over 4, -3 pi over 8, and then we have -pi over 2. So the period's pi over 2, so we're going to go from -pi over 2 to pi over 2. Okay. We've established that. The range is still all real numbers. Now, we definitely have a vertical shift down 3 units, right? Because of that -3, we have a vertical shift down 3. And then that 2 is negative on the tangent, so we have a reflection in both axes. We have a reflection in the x and y axes. This is all from the original tangent of x graph. And then let's take that 2x minus pi over 2. Let's set that equal to the, let's set that equal to 0. You would end up getting 2x equals pi over 2, which would give you x equals pi over 4. That means you have a horizontal shift right pi over 4 units. So we have a horizontal shift right pi over 4. Now, dealing with the domain and asymptotes is going to be a bit tricky, okay? We have 2 factors to consider. One, the period. So your normal asymptotes of tangent are what? They're going to be odd multiples of pi over 2. If you divide by that 2 for your period, that's going to start giving you odd multiples of pi over 4. Let's write that temporarily. X not equal to odd multiples of pi over 4. That's just based on the period change, but there's yet another change. We also have to take into account for this pi over 4, because everything shifted to the right pi over 4 units. So in reality, that's going to actually give us, once again, that would actually end up then giving us, let's see, so odd multiples of pi over 4, and then shift it to the right pi over 4, you'll end up actually getting, should be odd multiples of pi over 2. Yep, so you would actually end up getting odd multiples, once again, of pi over 2. If you shift it to the right pi over 4. So we really kind of just went back to where we were. So that means the asymptotes will be at x equals odd multiples of pi over 2. So let's go ahead and label this, only we have a smaller period to compete with, so this is going to get very interesting. So definitely negative pi over 2 is going to be an asymptote, but there's another asymptote you probably didn't expect. If it was originally odd multiples of pi over 4, which negative pi over 4 would have been 1, but you shifted to the right pi over 4, that actually gives you another vertical asymptote at 0. So actually you have 3 vertical asymptotes. Positive and negative pi over 2, and then again at 0. So this is going to be an interesting graph. Okay, so let's take pi over 8 for x. What does that give you? That ends up giving you, of course, 2 times pi over 8, which is pi over 4, minus pi over 2 actually gives you negative pi over 4. What's normally the tangent of negative pi over 4? That's normally negative 1, right? But you have a negative 2 on that, and so negative 2 times negative 1 is going to give you actually positive 2, but then you subtract 3, you're down to negative 1. Now let's put in pi over 4. So normally that would give you the tangent of pi over 2, then subtract pi over 2, you'll end up getting the tangent of 0, which is 0, and then minus 3 is actually going to be down to negative 3. And then let's take 3 pi over 8. Well, 3 pi over 8 is actually going to then end up giving you 3 pi over 4, but minus pi over 2 is the tangent of pi over 4, which is normally 1. Take that times negative 2, you'll end up getting negative 2 minus 3 is negative 5. So here's a really funny graph with all of the reflections and shifts, and then yes, it's going to do the same thing over here. So let's put in negative pi over 8. You'll end up getting the tangents of, so 2 times negative pi over 8 is negative pi over 4, minus pi over 2 is negative 3 pi over 4. Well, the tangent of negative 3 pi over 4 is normally positive 1, times negative 2 is negative 2 minus 3 is actually negative 5. Okay, let's put in negative pi over 4. That's going to give you the tangent of, so 2x times negative pi over 4, that's negative pi over 2, minus pi over 2 is negative pi, that's normally 0, then minus 3, you'll get negative 3. And then if you put in negative 3 pi over 8, you'll end up getting negative 3 pi over 4 minus pi over 2. That's normally going to end up being negative 5 pi over 4, which would be negative 1, times negative 2 is positive 2, minus 3 is negative 1. So yes, what a change. So here's your normal graph of the tangent of x with an amplitude of 2 reflected in the x and y axes, shifted downward 3 units, shifted to the right pi over 4 units. So that is an amazing transformation from the original to get this. And I got just one more, which you guessed will be a transformation on the cotangent function. Alright, f of x equals 2 minus 3 times the cotangent of 2x plus pi over 2. So f of x equals 2 minus 3 times the cotangent of 2x plus pi over 2. Well, let's start with our amplitude. The coefficient on cotangent is -3. So if I take the amplitude, take the absolute value of -3, I get an amplitude of 3. And then that negative does mean a reflection in the x and y axes. We got both of those covered. Now, what about for the period? The coefficient on x is 2, so you take that pi divided by 2, well, that's your period, is pi over 2. At this point, we have enough to label the axes, or the x-axis. So here's 3 pi over 8. Here's pi over 4. Here's pi over 8. All right, negative pi over 8. Negative pi over 4. Negative 3 pi over 8. And then negative pi over 2. All right. All the critical points are labeled from negative pi over 2 to pi over 2. Now, we can definitely ascertain that this positive 2 before the -3 cotangent, that's a vertical shift up 2 units. Your range is still going to be all real numbers. Now, where it's about to get fun is going to be with your horizontal shifts in your domain and your asymptotes. So take that 2x plus 2, set it equal to 0, you'll have 2x equals negative pi over 2, which is going to give you x equals negative pi over 4. Well, what does that mean? That means you actually have a horizontal shift left pi over 4 units. So you got a horizontal shift left pi over 4 units. And now we deal with the domain and the asymptotes. So what are your normal asymptotes of the cotangent function? They're normally the integer multiples of pi, right? Well, in this case, that's going to give you, if you divide those by 2, you would end up getting pi over 2. So really, that would be integer multiples of pi over 2. So let's start there. X equals integer multiples of pi over 2. Which means for your domain, x cannot equal integer multiples of pi over 2. But there's a whole nother thing to this. There's a whole nother thing. We still have that horizontal shift, which is also going to shift our asymptotes. So this is about to get very interesting. So integer multiples of pi over 2 actually, I need to correct that again, because it should really be odd multiples of pi over 2. No, actually, it should be even. X not equal to even multiples of pi over 2. Because let's see, 0 times pi over 2 is 0. Well, the cotangent at pi over 2 itself is undefined, but if I put in 2 for x, if I put in 2 times pi over 2, that would end up giving me pi. Now that ain't right. It was on the tip of my tongue, but let's look at this here. So yes, normally integer multiples of pi, it's true, are not going to be defined. But you have to divide by that 2 for your period. So any multiples of pi over 2 in theory would not be defined. Yes, because you would end up getting pi, or you would end up getting 0, or you would end up getting, yeah, except for 0 itself. If you put in x equals 0, you would get the cotangent of pi over 2, which is 0. But we have to shift it left pi over 4, which should actually put you then at pi over 4. Let me label these. Maybe graphing this will help us make sense. Sometimes it helps to graph. Alright, so 0 is normally an asymptote. Then you shift left pi over 4. Yep, so you would have another one at negative pi over 4. So in actuality, it's going to end up being odd multiples of pi over 4. X is not equal to odd multiples of pi over 4. So all of a sudden, this is starting to behave a lot like a tangent. So you would have asymptotes at x equals odd multiples of pi over 4. Sometimes it helps to work it out and graph your asymptotes too, so you can really see what you're working with here. Okay, let's go ahead and start graphing here. So normally 0 would be disqualified, but if we put in 0, you'll end up actually getting the cotangent of pi over 2, which is 0, plus a 2 would actually put you up at 2. Now let's put in negative pi over 8. 2 times negative pi over 8 is negative pi over 4, plus pi over 2 gives you positive pi over 4, which is the cotangent of positive pi over 4 is normally 1, but if you take negative 3 times that, you'll end up getting negative 3, plus that 2 gives you negative 1. And then if you take pi over 8, that would give you 2 times pi over 8, which is going to be pi over 4 plus pi over 2 gives you 3 pi over 4. Cotangent of 3 pi over 4 is normally negative 1. Take that times negative 3, you'll get positive 3 plus 2 is 5. So there is going to be your transformed graph to start with, and as you see, the cycle is going to repeat. Let's say I put in pi over 2, that would give me pi plus pi over 2. That's going to give me the cotangent of 3 pi over 2, which is 0 plus 2 is 2. If I put in 3 pi over 8, that would give me the cotangent of 3 pi over 4 plus pi over 2. That would actually end up being 5 pi over 4, which is normally negative 1. Yeah, that would give me, let's see. So, yeah, 3 pi over 4. So 5 pi over 4 is actually positive 1, excuse me. The cotangent of 5 pi over 4 is positive 1 times negative 3 is negative 3 plus 2 is negative 1. Let's come over here. negative pi over 2 for x would end up giving me negative pi plus pi over 2 would give me the cotangent of negative pi over 2, which is 0, plus 2 is 2. And now let's do negative 3 pi over 8. That would give me the cotangent of negative 3 pi over 4 plus pi over 2 would give me the cotangent of, let's see, negative pi over 4, which would normally be negative 1 times negative 3 is positive 3 plus 2 is 5. What an interesting graph. So here's the graph of the original cotangent function with an amplitude of 3, a period change becoming pi over 2 instead of pi, a vertical shift up 2 units, a horizontal shift left pi over 4 units, and a reflection in the x and y axes. So that's it for this lesson. Next lesson we're going to get into some inverse trig functions. So I hope everyone has a great day. Take care.